Hey everyone, thank you for joining us today. We have Daniel Gray, VP of Sales and Engineering from AtScale, and his colleague Cord Johnson. They will be beginning in just a few minutes as attendees continue to join. Just a quick reminder, a brief survey will follow at the end of the session. Please share your best moments at virtual conferences on social media, Facebook, Twitter. Use hashtag ODSC virtual. We have 30 prizes to give away today. Your feedback will help us shape future of this particular conference, and we love data too. Now I will give Daniel uh, so he can start presenting. Daniel, you can start now. Thank you.
Cool. All right, Daniel, you all set? This is Court.
Yep, I'm all set. Thanks, Court.
Yep, cool. All right, well, good morning, everybody. So I hope everybody is staying safe and remaining healthy out there. Definitely a fun experience here trying to do a virtual conference. So excited to talk to you guys today. We want to thank you guys for joining our session this morning. As you heard earlier, my name is Court Johnson. I'm VP of Growth at AtScale, and I'm here with my colleague Daniel Gray, VP of Sales Engineering. So today we're excited to talk to you guys about how Cloud OLAP can be used to analyze COVID-19 data. I know what most of you guys are thinking as data scientists. OLAP, what? I mean, this is a technology from the 90s, so how is this relevant to me and the predictive analytics work that, I really care about? So the short answer is we agree. Traditional OLAP is dead. But what we want to show you guys today is Cloud OLAP. So take the parts of being able to do performant ad hoc what-if analysis on a modern cloud architecture without all the baggage of that traditional OLAP. And then today, you'll see how you can analyze the impact of COVID-19 data without all that data engineering and make your lives ultimately as data scientists a hell of a lot easier. So just as an introduction, we are from AtScale. We're an analytics company. We're in a unique position as an analytics company to help make sense of data in real time. And with the COVID-19 data, our objective is to remove the time-consuming data engineering required to analyze this data. So in today's session, we're going to cover a couple of things. And Daniel, I don't know if you want to hop over. Okay, cool. So we'll show you, or we'll talk to you guys about the value of Cloud OLAP when analyzing data. We'll give you guys an overview of the COVID-19 data set that will be available later today for analysis, and we'll give you the link to register on our site to get access to it. And then we'll take you through the first iteration of the model as it is today and show you guys a little bit more about how it's going to evolve over time. And then finally, we're going to show you guys how you'll be able to connect live to this data through Tableau and Excel to start. So if you have any questions, please feel free to ask. We'll save some time at the end, roughly 15 minutes for a Q&A session. If we don't have enough time to answer your questions specifically, please feel free to reach out individually and we'll follow up with you directly. So with that, why don't I hand it over to Daniel Gray.
Thanks, Court. Okay. All right. I appreciate the time everybody's taken this morning. Part of this started, with the data set that Snowflake released last week from the Star Schema folks, and so it's a set of tables that you can access in Snowflake, and I'll show it to you here in a few minutes, and do some analysis. It's an interesting data set. It's not necessarily relatable across different facts and different dimensions, and so you really have to pay attention to how you're analyzing the data, how you're building your quantitative values, and how you're relating data to ensure that you get the correct values back and you interpret the data correctly. And so after seeing that data set, we thought, why not quickly model that data? And I'll kind of walk through what modeling means from our perspective, and then get it out there to the public so folks can do analysis on that data. We're not necessarily providing predictive models for folks to go out and make predictions. That's an area that you really need to have, expertise in the subject area to be able to do that. And we don't want to make any false predictions. What we really do is focus on building models that allow you to do what-if analysis and slicing and dicing the data in a very efficient way without doing any complex ETL or cleansing of the data or trying to define the basis of different quantitative values. We just give you the ability to quickly go out and do analysis, and we kind of do all the hard work behind the scenes, and I'll walk you through how we do that. But ultimately, it's not necessarily about making a pitch for a product. It's about, providing a model that people can go access. A lot of our customers use things like Tableau and Excel, so you have the ability to connect those up today, but there's nothing to prevent you from connecting a Python notebook in and doing your feature engineering directly against the model. And, it's extremely performant, and we're going to continue to add to it, and we're going to walk through kind of what we plan on doing. We'd love to get your feedback. If you use the model and you build anything cool or you have any questions, we'd love to get your feedback and love to be interactive. One of the things that Court talked about earlier is that traditionally when you hear OLAP, you think of old school technologies, and a lot of people I work with that focus strictly on machine learning, they were never even exposed to OLAP. And so back in the day, for the folks that were, we didn't have technologies 15, 20 years ago that were necessarily were similar to things like Snowflake today, or even Hadoop or Spark, or that is, MPP, much more scalable. So we had to come up with ways to make slicing and dicing of the data efficient. And out of that, came the school of thought of OLAP and cubes. And, that worked for a little while, but on today's data sizes and more importantly, kind of the pitfalls of OLAP around pre-materializing data, so pre-computing data, moving data, organizing data for some, path of, analytics path that ahead of time is not very agile. And so OLAP cubes. So you can think of things like Hyperion cubes, Essbase cubes, Microsoft Analysis Services cubes, have started to go by the wayside just simply because a lot of the new technologies out there today promise the ability to do that slicing and dicing on the data. But anybody who's doing analysis today and is taking quantitative values and doing slicing and dicing of that data across geographies, across time, across demographics, chances are, if you're doing that on a big Spark cluster, or even if you're doing it in something that elastic like Snowflake, you're still doing data engineering behind the scenes to make it performant and to kind of cleanse the data so that that when you look at a quantitative value, a metric of some sort, that it is valid and that it's not going to impact any of the modeling that you're doing. And so AtScale basically turns OLAP on its head. We don't have any of the negative. You don't have any kind of the luggage that comes with traditional OLAP. So what we essentially do is we moved away from pre-aggregating data, pre-materializing data, or anything else. We have kind of the best of both worlds. So we provide basically a semantic model. And what that means is ability to go define your measures, your quantitative values, and your categorical information. So your kind of your who's, what's, when's, and how's, all in a governed way through a universal semantic model. So I'll give you an example of how some of our customers, especially around machine learning, are using AtScale. So today, without AtScale, or say previously without AtScale, they would go through, they would do machine learning. They would end up getting results that didn't make sense. So then their data scientists would spend a lot of time in Python, essentially building out facts and dimensions and redefining metrics and how they slice and kind of the intersections of those data to understand where their features were incorrect, where their analysis was incorrect. And they spent more time doing that than they spent actually doing machine learning and building predictive models. And so with AtScale, and I'll show you an example of this in a second, we have a universal semantic layer where folks that are familiar with the metrics, sales tax, sales, patient counts, all the way down to like the complex business constructs, folks that understand those constructs can define the semantic layer around those and provide them out for people to consume regardless of the tool. It could be Tableau, it could be Excel, it could be Python. But when you use the semantic model, you're getting a definition that is accurate, and each and every one of those tools are going to report back the same values. And so that's part of what you get with a traditional OLAP cube, where you still get that capability with AtScale, and it's universal in nature. And so you're not redefining those business constructs in Python. You don't have business users doing that in Tableau and Power BI, and you don't have finance users using Excel and redefining that. You get one single place. And then the other side of it is essentially where we use machine learning. So instead of pre-aggregating data, taking data off of Spark and moving it somewhere else into a cube, or taking data off of Hadoop or traditional Hadoop or Snowflake and putting it into a pre-aggregated cube, we don't do that. It's not agile, and there's a lot of negative consequences that come with that. We actually use machine learning within our product to look at the different query patterns that come in from the different tools and automate the data engineering required to get the best possible performance. So when you're doing feature engineering for your models, you don't need to wait minutes, seconds. You don't need to go out and build data structures and make things faster. It's just automatically done for you behind the scenes, including kind of bringing data together from different data silos so that you can query different data silos. And we call that autonomous data engineering. And so if you take the universal semantic layer and you take the autonomous data engineering and you put it together, it gives you all the benefits of online analytical processing, which we all do, regardless if OLAP has a negative connotation or not. We all do online analytical processing. We just take all the bad baggage away from traditional cubes, and we just do it in a kind of a different sense. And I'll walk you through some examples of that today. But again, really, this was about taking the Snowflake data set, which I'll pop over and show you in a second, and essentially building a semantic model around that. So spending a little bit of time trying to understand the data, and then exposing that semantic model so people can go off and do analysis. And I won't show you any really pretty reports or graphs in Excel or dashboards in Tableau. It's not something that I really focus that much time on. For me, it was more about the model. Because if I can define the semantic model ahead of time, then the experts in machine learning can go off and quickly do feature engineering and build predictive models. The experts that use something like Tableau can go out and build reports that people can consume. And so that was really our focus. We've exposed that model, and here at the end, we'll provide you an email address if you guys are interested in accessing it. And so with that, that's kind of from a high level, that's the AtScale product. It's why it's different than traditional OLAP. And I'm sure a lot of you guys, as you came on the line today, you saw OLAP and thought, how is this going to be applicable to me? Really what we're talking about is the ability to do fast multidimensional analytics. And I'm sure, as you know, as you're developing models, predictive models, you have to slice and dice the data to understand how to engineer your models. And so we give you that ability. So with that, let's actually move into some little bit of interactivity here. And again, nothing super, let me move my, sorry about that. Should have done that before I started this. I apologize. All right. So nothing, not a lot of time spent building pre-dashboards. So again, we just wanted to get the model out. But essentially, if you go out to Snowflake, if you have a Snowflake account, you can access this data today. If you just want to access the model, just let us know, and we'll give you access through either ODBC, JDBC, or MDX endpoint, so you can connect up different tools. If you're familiar with the Snowflake data, this is a dashboard that's been built on top of that data. I'll just pop over here real quick. 1 second, and just kind of bring up the Snowflake data set. Hopefully you guys can still see my screen. So if you log in, there's a COVID-19 data set in the Snowflake public share. And there's a bunch of different tables here that they've exposed. And since last week, they've been adding new data sets. They have a nice metadata table that will tell you a little bit about some of these tables. A lot of them don't have that information quite yet. But as you look across here, you can see data from the WHO, which is more or less a global report of the data that we're building a model around. You can also you can see data around kind of U.S. state mitigation. So this is like when they shut down schools, when they shut down bars, when they implemented social distancing. You can also see information around when airlines started enforcing restrictions. And then you can start to see that right here is kind of a general U.S. COVID test data fact table, if you will. And then you can see the Johns Hopkins University data. You can see the New York Times has some COVID data. If you start to look down here, you can actually see in here, there's also a German data set, there's an Italian data set, there's a Canadian data set. The important thing that I would draw out here is if you just go look at this data, it's not necessarily all relatable. They have one particular demographics table here that's really US based. And there is no global information here. So if you just start writing SQL in a Python notebook, or just doing some really simple type of SQL exercises on this data, you're very likely to get the wrong answer, because one, the categorical information is not relatable necessarily to the facts. So you need to be super careful. So you could spend a lot of time writing a lot of SQL to try to understand how to relate this data. Another interesting thing to look at here is if I pull up something like this COVID data, it's basically what we call like a semi-additive measure. And what I mean by that is that, as you can see here, the Alabama data that's been presented back increments over time. So every single day they're reporting basically the new value of the positive, the number of positive counts for that particular day. But it's actually a sum of the values. So if you're not careful and you sum this entire row, so you just go out there and say, sum positives by United States by Alabama, you'll get the wrong value. And so what you really have to do is you have to start writing probably a analytic that uses like last value. So start using a Windows calls and SQL. It's not rocket science. If you're a SQL guru, you can sit down within a while and probably figure something out. Chances are what you're really going to do is probably start to write ETL jobs to bring this data together. That way, when you consume it or when you expose it to people, it's really easy and consumable, and you're not on the phone all day trying to explain how to build a join. But again, so this is the data set. It's available. We took a look at it and we thought, well, what if we modeled this and we tried to expose a more governed model where folks don't need to worry about, hey, should I write a last value window clause here? And what happens if I accidentally join Italian data to a demographic table that doesn't have any Italian data in it? Will my results be incorrect? How can I ensure that if someone uses the data that they are not drawing some wrong conclusion? And especially in your industry, where if you draw the wrong conclusion, you build the wrong predictive model, there's consequences associated with that. So that was really our goal. Again, it wasn't really to go out and build the analytics. We have specialists that can do that. Our goal is to, we basically started off, we built a model around the Johns Hopkins University data set. We built a model around the US COVID data set. We're working on the German model and Italian model now, and we're going to kind of bring all those together. Every day that you log into our model, you'll see these new constructs. The reason for that, again, is that we don't have to build a physical cube. So we go out and find some new stuff. We find something new and interesting. We quickly add it to our model. And so let's just show you what that looks like real quick. We quickly add it to our model, and then we publish our model, and it's available for consumption immediately. And it doesn't matter if the data is in a form that is performant, because we're going to look at those queries that you're issuing, and our machine learning is going to understand the different patterns of the different queries that are coming in. And we're going to use that along with some statistical modeling, and we're going to automatically build out the data structures on Snowflake in this particular case that ensures that the queries that you're running are extremely performant. And so that way, when you're asking your questions, you're getting to the root of the problem, and then you're making a decision and doing something about it versus going to grab a cup of coffee. So with that, again, if we look over, I could pull back up other tables, but I'm sure you didn't memorize all those table names, but you can start to see the CT US COVID data set here. I started to pull in state mitigations. I pulled in, I built a geo dimension table. So this allows you to slice and dice by state and by county and by country. We have a nice date dimension. This allows you to do time series analytics. So you can start to do things like period over period analysis. So, what are the number of new cases versus the same period last week? And you can start to build that kind of complexity directly into your model here, so that downstream, anybody who consumes this model, they don't need to redo any of that work. Just go off and do your analysis and then do what you have to do from there versus worrying about writing complex SQL, ETL, or doing data engineering to make sure things are performant. And then also just kind of starting to bring in some additional fact tables that we found in there, and frankly, some other data sets that we found out. So this date dimension is actually not part of that data set that I showed you. It's another data set somewhere else completely on Snowflake as a part of another one of their sample data sets. US Census was a different data set that we just started pulling together. And so we'll pull all this together within the model and we'll expose it. But the end consumer, and I'll explain how this is applicable to really the machine learning community in a second. The consumer of this model, this is what they essentially see. They see measures, so you see your quantitative values, and you see your kind of your who's, your what's, your wins, and your hows. So in the case of the business intelligence community, all they have to do is slice and dice. They don't care if some of the data sits in Snowflake, some of it sits in Spark. They don't care about if it's a denormalized table versus a star schema. All they see is this information. They drag and drop it. They feel confident that it's accurate information because someone has built a governed model. And then they're often going and doing their work. In the case of someone like using a Python notebook, we expose a SQL interface. And so when we publish this particular model, I'm just going to take 1 second here and go back to our published model. 1 second. And this is the model that I showed you. You can actually just connect in with JDBC or ODBC, and you can run SQL directly against the AtScale model. And so you can write SQL, but the key is you'll never write a join. You'll never need to do any type of transformation. What we expose from the end user, and I'll show you an example of this in a second, is just a flattened view of that model that I just showed you. And so what you actually end up seeing is just a really simple model that is basically just flattened, and you don't have to write any queries, you don't have to join any data together. Essentially, you can just query directly against a flattened cube. And then you're off. You're getting the same benefit of the universal semantic layer. You get the benefit of all the autonomous data engineering we're doing. And your SQL that's coming into AtScale is super simple to write because you don't need to worry about joining all this stuff. We've already done it for you, and we've just exposed a flattened interface. And so that's essentially what we wanted to do. We're opening this up. We've got a webinar this afternoon where we're going to go ahead and open this model up to anybody who wants to connect in. Again, as you look at that particular this particular model, this is our U.S. COVID data. This is our Johns Hopkins data. There will be an Italian and German data set in here this afternoon. You can just connect up and basically start doing analysis directly on the fly. I'll show you quickly some analysis I've done in Tableau and in Excel. I'm not sure anybody on the phone here is a big Excel user, but the point here is just kind of the universal semantic layer. I'm not a big report writer or dashboard writer, so you're not going to see anything fancy here. We're more interested in our community using this and providing some examples. Our main focus has really been around exposing the models for folks. So if I just quickly, just looking at the time here, if I quickly jump over to, that's not a good one, probably not too interested in that. I started, so the first thing to kind of look at is that, and again, I'm going to try to bring this back to what it would look like in Python in a second to make it more, maybe more, something that you would be more used to working in. But generally speaking, typically if I plug Tableau into that Snowflake data set, I would go down here to data source and I'd spend a bunch of time figuring out how to join those tables. I'd spend a bunch of time writing complex SQL to make sure, hey, am I grabbing the last value based on the timestamp, based on the geography to ensure that I don't have an incorrect value? I'm figuring out, wait, if I join a dimension that doesn't have dimensionality across one fact and across another one, am I going to get the right data sets back? Before I ever do anything, with AtScale, you just log in. Here's your different measures. Here's your semi-additive measures, kind of some of the things I talked about earlier. There's some sensor data here that you can start to do analysis. There's some medical facility data here. There's a bunch of other types of measures. And as you log into our model, you're going to see more and more of this over the next week or two as we just continue to pump out new measures and dimensions and hierarchies. And then ultimately, you see your things like your who's, your what's, your wins, and your hows. So you can quickly do analysis based on time. We're starting to add some other indicators in here because it's kind of interesting as you start to apply like weekend data and haul, and some of the other attributes of time in here. You can start to see some pretty interesting patterns. And then, of course, in this particular case, this is U.S. geometry data, geodata that we use. All right, sorry about that. And you can basically do slicing and dicing the data. You can start to build out, I'm kind of building out an animation here that will show, kind of the increase in positives over the last month and a half. And you can start to see some interesting patterns around, kind of, this, but not everybody's talking about false negatives. You can start to see, some really interesting patterns around that as you start to look at the data. And there's a lot of different things. This is just a snapshot of today. This is currently what we have today. But the important thing, the reason why I have this simple table here is that if I didn't do the right things with the model, and I essentially eliminated some pretty simple stuff here, and you weren't super careful about how you're analyzing that data, that would be your numbers. Because essentially, unless you spend a bunch of time in the data, understanding how the data is being populated, and you just start summing things and you just start running analytics against the data, you're likely to get the wrong answer. And so for us, it was a lot about building the governance around the data so that people can start making really accurate decisions. I won't spend a lot of time on this. I don't know how much time you guys spend in Excel, but I was just building a pretty simple kind of diagram here. But the important thing is, if you have someone that happens to like Excel, there's still 700 million something users of Excel out there. So, you get the same semantic model again that we had before. So you have your measures, your quantitative values, you have your date dimension hierarchies, you have your geography dimensions, and this is going to increase. So every single time you log in with one of these tools, you're just going to see more and more stuff that you can go do analysis with. And I'll just finish up with just a couple last notes here and try to make this more applicable to this audience. A couple of interesting things is that we use machine learning too. And so if I pop in, I just jump back here and let's just rerun. Let's rerun this particular query here. Refresh this data source and rerun this query. Let this run for a second and render here on my screen. I jump back to AtScale. The first thing, for this particular audience that's really interesting here is, that. I pop this open. This is that incoming query from Tableau. This is what you would be writing in a Python notebook. I know that in order to pull across these different measures and go across time, there's a join here, plus there's some complexity. This is where you'd write a bunch of windowing calls to make sure you grab the last query. Then you'd write your aggregate function. Then you'd write a join. In this particular case, probably a left join. Kind of depends on what you were trying to do. And then if everything works out, you get it back, and then you're probably going to go validate all that data's right. And then you're going to start doing your analysis. This is what all Tableau sends to us. There's no join. There's no nothing. It's a very simple flattened model is what you see, because we've done all the hard work of joining the data. We've done all the hard work to ensure that we have things like semi-additive measures to take advantage of, because we understand the knowledge of the data. And then essentially, we're spitting out the outbound query to Snowflake. If this data happened to be in Spark, we just generate a Spark query or whatever. And then, what we're doing in the background, instead of reading raw data, there's large data sets that they have out there, we're actually hitting what we call acceleration structures. These are things that we've actually built ourselves to make things fast. And we do that through automated data engineering. So you can see all these like acceleration structures we built on Snowflake. These are all defined based on different query patterns that people coming in and using the analysis. So if you go off and you do something radically new, which we hope folks do, AtScale is just going to detect that. We're going to use our own machine learning to go out and predict kind of what you're doing and what you may do next. And we're going to build acceleration structures to make that data super fast. And I'll just finish with like one last comment here, right up on the time for opening up for questions, is that I didn't have a chance to pop open my Python notebook. I got a new Mac here, so I was just kind of configuring it actually this morning. So I've got a little bit more work to do there. But I did want to pull something up. I just pulled up a lending tree risk analysis, some work I was doing last week. And I was looking at this particular model that we have out there that was developed a couple of years ago. And if you look at this particular model, it's around, I want to say 700 lines long. And if you look at the first 600 lines of this code, it's what if multidimensional analysis all the way through this code. And that's because he's engineering his features. And he's trying to find the appropriate features to use for, I believe he starts using logistical regressions and some other algorithms down below. But essentially, this is all what if type of analysis that he's doing directly here within his Python notebooks. Same thing I was showing you in Tableau. And if you see, he's writing complex SQL, and then he's doing also some engineering of the data to make it performant. And then finally, all the way down here towards the bottom of his code, right here, he starts actually doing machine learning. And so this first 600 lines of code here, all that was done through what if analysis and multidimensional analysis. We provide a mechanism to do that same analysis very easily with simplified queries. We bring the data together so that there's no confusion around where to find the data and how the data comes together. We do it in a secure manner, and we make it very performant. And then that way, instead of spending time trying to write complex SQL, do transformations, bring data together, go back and debug why a quantitative value is wrong because maybe the wrong calculation was applied to it, you're able just to go in and focus on what you actually really are focused on, which is machine learning. So let me just stop there. I guess at this point, do we open it up for questions, or do I turn this back over? Yep. So that's the presentation part of the webinar this morning.
Hey, Daniel, why don't you just show the slide that has the link to where people can go if they want access to the model?
Oh, yeah, yep. Sorry about that. Yes, you want to hit this one, Court?
Yeah, so thanks everybody for taking the time to join us, and we if you do have questions, we would love to hear them. But more than anything, part of the goal that Daniel's been talking about is being able to open up this model for folks like you to be able to get in there and do analysis. So you don't that literally the only thing you have to do is be able to connect ODBC, JDBC, or MDX to our MDX endpoint. You don't need Snowflake. You don't need AtScale specifically. And if you go to that link there, atscale.com/COVID-19, you can request access to get to connect the tool you'd like to the model and begin to do analysis. And the only thing that we'd ask is, if you find out anything interesting or if there's things that you'd want to share, we'd love to highlight that with you guys. And there's an email address, covid19@atscale.com, that we can provide where you can email and get connected to the team here to help showcase that. So all in all, that's what we wanted to highlight today, but happy to answer any questions that you folks have. And ODSC team, I'm not sure what the best avenue is to do that. So any help you can provide, we'd be eager to understand. All right, nothing from the ODSC team. Actually, I just opened up the question section. Daniel, did you try anything like clustering or forecasting within Tableau for the data?
No, I didn't. I'm going to spend some more time on. I'm trying to open up the questions here myself so I can see them. There's a way to expand this window here. Maybe not. Okay. Did we just lose? Oh, hopefully you guys didn't lose the voice. So we did not try any clustering. There's nothing to prevent us from doing that. I just started working on some of the dashboards this morning because the focus has been getting the model out and making sure that we had the infrastructure set up for folks to log in and start using it. So that's kind of my next step, is to do that. We also have a team of people internally that are going to start building some dashboards off it. But there's nothing to prevent. I mean, if I could jump in, I was just literally doing some development right before we started this. So there's nothing to prevent me from using these dimensional attributes and these quantitative values to do any type of analysis here. The one word I'd stay away from is predictive, because we've really looked at this as we're doing everything we can not to draw too many conclusions from or to predict anything that is going to happen. We don't mind looking at the past and trying to figure out what happened to push around some of this analysis, but we're not doing anything too forward looking, because we don't want to draw anything incorrect analysis. So hopefully that answers your question.
There's another question here about if it's free, and the answer to that is yes. So it is free to connect to this model. I provided the link in the chat, and then I'll follow up with the ODSC team to share it with you guys as well. Yeah, all we ask is you register on the site so that we can email you directly the instructions on how to connect with AtScale. There's another question here on where can we find the presentation slides. So we will have these slides posted on our website, but we'll share them with the ODSC team too. So if there's a place that they want to host them, happy to share these out as well. Yeah, there's a question here about wanting access to the model but not having a Snowflake account. And Daniel, you can correct me if I'm wrong, but as far as I understand, the user doesn't need to have the Snowflake account. It's all hosted through AtScale. So we are the ones that are providing the compute. All we're asking for from the end user is, again, share any interesting insights that you come up with so that we can get them out to the overall community.
Yeah, that's correct.
Only U.S. model open for access.
It is right now. So the two models that we've exposed is the U.S. and the John Hopkins. And John Hopkins is actually is actually a worldwide model. So if we go back and if you take a look, here, one second. We'll provide, if you log in, you're interested in seeing this, we'll actually provide you information on how to get access. But the Johns Hopkins University data set is actually a global data set. So if you take a look at that, you'll see global data sets. But the one thing that we noticed out in Snowflake is that there's starting to be individual country fact tables popping in there now. And so we're starting to build individual models around each one of those. And, within AtScale, you can actually kind of join all that data together to start drawing some really interesting conclusions about, effectively, why are people reporting the data differently? Because that's one of the things that you'll notice, and you can actually draw some pretty interesting conclusions from that. So we're gonna also do that. So as you log in and you do, and you're provided a TDS file for Tableau, or you just log in with Excel or Power BI, you'll start to see more and more of these models out there that you can consume. But yeah, so to answer your question, John Hopkins model here does have worldwide data.
Perfect. And it looks like we do have some people registering for access. And again, we'll be emailing folks later this afternoon, Eastern time, with instructions on how to connect. And then we will be hosting another webinar via AtScale next Friday. And we'll just keep giving updates to the community on how the models evolve, what you have more access to do. And we'll share some community insights on those webinars as well. So if you do find anything and you do want to share, we have a nice vehicle to help promote the work that you guys are doing. The model and data is used, it will be cited. We'll share anything. Okay, yeah, great. Thank you. Any other questions before we wrap up with a minute remaining? All right. Well, thank you guys all for joining us today. Hopefully this was an informative session on how Cloud OLAP can help you guys as data scientists do your work more effectively. We're excited to get you guys set up with access to our AtScale model if you're interested. And if you do have questions, feel free to reach out via the AtScale website, or there's a COVID-19 at atscale.com email address where we'll be able to get in touch with you immediately. And with that, I'd just like to thank the ODSC team and the community for including us today. We're excited to see what the community is able to learn from having access to this data. So thank you.